transistor act as amplifier. See here, this is a block diagram of amplifier. It consists of input supply, input resistance and load resistance and output supply. Input signal is converted into output signal by increase its strength. So that means amplifier, it is a device, electronic device which amplify the signal and convert weak signal into strong signal. See here, in order to magnify the input signal, all the amplifier need a source of energy. So we required source here to amplify this given input signal and convert into larger form. So this may be provided by battery or a DC power supply or AC. It may be AC or DC. The DC power supply is also essential for biasing. You know that biasing is the provision by which we can provide external supply to the BJT. So there are two types of biasing, forward bias and reverse bias. So the DC power supply is also essential for biasing the BJT used in the amplifier circuit. The amplifier should contain at least one active device such as transistor or FET, BJT or FET, bipolar junction transistor or field effect transistor, or an operational amplifier, that is op-amp. In analog and digital signaling, this op-amp is very important. If a transistor is used, then it should be biased in active region. So you know that there are three regions of operation of transistor. Which are those? Active region, cutoff region and saturation region. So for operating transistor act as amplifier, it should be operating in active region. It should be operate in active region. Okay. So what are the characteristics of amplifier? So these are the characteristics of amplifier. First one is a voltage gain. Voltage gain, it is a ratio of output voltage to the input voltage of amplifier. That means amplifier, it is a device which convert weak signal into strong signal. Amplifier is an electronic device which convert weak signal into strong signal. So here, for selection of this amplifier or specify this amplifier, we consider voltage gain. That means output voltage by input voltage. How much input is provided here and we get how much output from this input, that is the voltage gain. It is a ratio of output voltage to the input voltage. Then current gain. Current gain. Here also we calculate the output current to the input current of transistor or amplifier. Then input resistance. This is the input resistance. By maintaining input resistance, we can vary the current gain and voltage gain. Similarly, output resistance, that is load resistance. By varying the output or load resistance, we can vary the output. What is power gain? It is a ratio of output power to the input power of an amplifier. So this this characteristic is also important for the selection of amplifier. And last one is bandwidth. Bandwidth, it is a range of working area. That means how much area or how much percent signal is amplified. So that is bandwidth. Okay. how much percent signal is amplifier, or how much range of that working amplifier is nothing but bandwidth. So these are the characteristic of amplifier. See here once again, voltage gain, it is a ratio of output by input voltage. Current gain, it is a ratio of output by input current. Input resistance, that is resistance at source side. Output resistance, that is resistance at load side. Power gain, it is a ratio of output power by input power. Then bandwidth, it is a range of working area of that amplifier. So these are the amplifier characteristics. So there are two types of amplifier. Which are those? Current amplifier and voltage amplifier. So in this lecture we will discuss about transistor as a current amplifier. Transistor as a current amplifier. When C configuration is used, you know that when C, that means common emitter configuration is used, the relation between I and IB. So beta is equals to IC upon IB. You know that beta is equals to IC upon IB. We already discussed about this. We have taken too much, I think 4 to 5 problem on this. So beta, it is a current gain and it is a ratio of output current by input current. Output current by input current for C configuration. Then current gain is equals to output current by input current, that means IC by IB, that is a beta. Okay. And for CC configuration, IE is equals to 1 plus beta into IB. For CC configuration, IE is equals to 1 plus beta into IB. That means for CC configuration, IE divided by IB is equals to 1 plus beta, where beta is a current gain. Beta is a current gain. As the value of beta is much higher than 1, you know that for from your calculation, value of beta is 49, 58, 95 from previous examination numerical. The value of beta was 49, 58, 95. That means it is too much more than 1. So from this we can say that the current gain of C and CC configuration is large. Hence for a small change in input current, we get a large change in output. For small current, small change in input side, we get large current, large change in output side. That means we can convert small signal into large signal. So thus current amplification take place and transistor act as a current amplifier. Note that in CB configuration it is not possible. In CB configuration it is not possible. Why? Why? Because in CB configuration value of beta is not considered. Okay. So value of beta is not much more than 1. So that's why in C and CC both configuration current amplification take place, but in CB configuration current amplification does not possible. So that's why current amplification only take place in C and CC configuration and not in CB. Are you getting this? So write down this.